Automobile air conditioning systems cool the occupants of a vehicle in hot weather. History: a company in New York City in the United States, first offered installation of air conditioning for cars in 1933. Most of their customers operated limousines and luxury cars. The Packard Motor Car Company was the first automobile manufacturer to offer an air conditioning unit into its cars, beginning in 1939. These air conditioners were manufactured by Bishop and Babcock Company, of Cleveland, Ohio. The Bishop and Babcock weather conditioner also incorporated a heater. Cars ordered with the new weather conditioner were shipped from Packard's East Grand Boulevard facility to the B&B factory where the conversion was performed. Once complete, the car was shipped to a local dealer where the customer would take delivery. Packard fully warranted and supported this conversion, and marketed it well. However, it was not commercially successful for a number of reasons. The main evaporator and blower system took up half of the trunk space. It was superseded by more efficient systems in the post-war years. It had no temperature thermostat or shut-off mechanism other than switching the blower off. The several feet of plumbing going back and forth between the engine compartment and trunk proved unreliable in service. The price, at $274, was unaffordable to most people in post-Depression pre-war America. Subsequently, the option was discontinued after 1941. Chrysler AirTemp equals. The 1953 Chrysler Imperial was one of the first production cars in 12 years to offer modern automobile air conditioning as an option, following tentative experiments by Packard in 1940 and Cadillac in 1941. Walter P. Chrysler had seen to the invention of AirTemp air conditioning in the 1930s for the Chrysler Building, and had ostensibly offered it on cars in 1941-42, and again in 1951-52. The AirTemp was more advanced than the rival automobile air conditioners by 1953. It was operated by a single switch on the dashboard marked with low, medium, and high positions. As the highest capacity unit available at the time, the system was capable of quickly cooling the passenger compartment and also reduce humidity, dust, pollen, and tobacco smoke. The system drew in more outside air than contemporary systems, thus reducing the staleness associated with automotive air conditioning at the time. Instead of plastic tubes mounted on the rear window package shelf as on GM cars, small ducts directed cool air toward the ceiling of the car where it filtered down around the passengers instead of blowing directly on them, a feature that modern cars have lost. Cadillac, Buick, and Oldsmobile added air conditioning as an option on some of their models in the 1953 model year. All of these Frigidaire systems used separate engine and trunk-mounted components. Nash integrated system equals. In 1954, the Nash Ambassador was the first American automobile to have a front-end, fully integrated heating, ventilating, and air conditioning system. The Nash Kelvinator Corporation used its experience in refrigeration to introduce the automobile industry's first compact and affordable, single-unit heating and air conditioning system optional for its Nash models. This was the first mass-market system with controls on the dash and an electric clutch. This system was also compact and easily serviceable with all of its components installed under the hood or in the cowl area. Combining heating, cooling, and ventilating, the new air conditioning system for the Nash cars was called the All-Weather I. This followed the marketing name of Weather I for Nash's fresh air automotive heating and ventilating system that was first used in 1938. With a single thermostatic control, the Nash passenger compartment air cooling option was described as a good and remarkably inexpensive system. Entirely incorporated within the engine bay, the combined heating and cooling system had cold air for passengers enter through dash-mounted vents. Nash's exclusive remarkable advance was not only the sophisticated unified system, but also its $345 price that beat all other systems. Automatic climate control equals. Most competing systems used a separate heating system and an engine-mounted compressor, driven by the engine crankshaft via a belt, with an evaporator in the car's trunk to deliver cold air through the rear parcel shelf and overhead vents. General Motors made a front-mounted air conditioning system optional in 1954 on Pontiacs with a straight-eight engine that added separate controls and air distribution. The alternative layout pioneered by Nash became established practice and continues to form the basis of the modern and more sophisticated automatic climate control systems. Growth in demand equals, air conditioning for automobiles came into wide use from the late 20th century. Although air conditioners use significant power, the drag of a car with closed windows is less than if the windows are opening to cool the occupants evaporatively. There has been much debate on the effect of air conditioning on the fuel efficiency of a vehicle. Factors such as wind resistance, aerodynamics and engine power and weight must be considered, to find the true difference between using the air conditioning system and not using it, when estimating the actual fuel mileage. Other factors can affect the engine, and an overall engine heat increase can have an impact on the cooling system of the vehicle. The innovation was adopted quickly, and by 1960 about 20% of all cars in the U.S. had air conditioning, with the percentage increasing to 80% in the warm areas of the Southwest. American Motors made air conditioning standard equipment on all AMC Ambassadors starting with the 1968 model year, a first in the mass market, with a base price starting at $2,671. By 1969, 54% of the domestic automobiles were equipped with air conditioning, with the feature needed not only for passenger comfort, but also to increase the car's resale value. Operating principles refrigeration cycle equals. In the refrigeration cycle, heat is transported from the passenger compartment to the environment. A refrigerator is an example of such a system, as it transports the heat out of the interior and into its environment. Circulating refrigerant vapor enters the compressor and is compressed to a higher pressure, resulting in a higher temperature as well. The hot, compressed refrigerant vapor is now at a temperature and pressure at which it can be condensed and is routed through a condenser, usually located in front of the car's radiator. Here the refrigerant is cooled by air flowing across the condenser coils and condensed into a liquid. Thus, the circulating refrigerant rejects heat from the system and the heat is carried away by the air. The condensed and pressurized liquid refrigerant is next routed through an expansion valve where it undergoes an abrupt reduction in pressure. That pressure reduction results in flash evaporation of a part of the liquid refrigerant, lowering its temperature. The cold refrigerant is then routed through the evaporator which is located in the passenger compartment. The air blows across the evaporator, causing the liquid part of the cold refrigerant mixture to evaporate as well, further lowering the temperature. The warm air is therefore cooled. To complete the refrigeration cycle, the refrigerant vapor is routed back into the compressor. The compressor can be driven by the car's engine or by an electric motor. Evaporative cooling equals. A car cooler is an automobile window-mounted evaporative air cooler, sometimes referred to as a swamp cooler. It was an early type of automobile air conditioners and is not used in modern cars. To cool the air it used latent cooling of vaporization. Water inside the cooler evaporates and in the process transfers heat from the surrounding air. The cool moisture-laden air is directed to the inside of the car. The lower the humidity, the better the system works. Because of the dry desert air, car coolers were popular in the southwestern United states of California, Arizona, Texas, New Mexico, and Nevada. Power consumption. In a modern automobile, the AC system will use around 4 horsepower of the engine's power, thus increasing fuel consumption of the vehicle. See also, air conditioning. References. External links, air conditioners for your car. Popular Science 194, 117 132, includes detailed drawings. April 1969. Retrieved April 16, 2015.